Hi guys, in this project I'll be showing you how to interact your motor using a PWM concept as well as ADC concept. So this whole is a Proteus simulation for those who are new to it. I've already discussed about in my previous topic. The topic was ADC interfacing with 8051. Do search it on Engineer's Garage. So you'll get to know more about it. And so here's my ADC. It's ADC0804. That's my 8051 microcontroller chip. That's the 16x2 LCD. And here's my L293D motor driver IC. And here's my DC motor. These two presets over here are for this one is for giving half the reference voltage for this ADC. Reference voltage over here is 5 volts, and this preset over here, it gives the analog values to this ADC, and then this ADC converts the analog value to the digital 8-bit data, which is further transferred by these DB pins to the port 1 of the microcontroller, and then I've copied the values of port 1 to port 3, which further gives the data to the LCD to display the decimal values on this LCD. So what's happening in this project is I have used this preset to control the motion of the motor. So like if I move let me simulate this project. Since it's in the mid position, so the value it gives is 128, which is half of 256. And in my coding part, what I've done is I've done, like, if you want to move, the motor will move in both the directions, clockwise as well as in anti-clockwise, which depends on which direction you move your pointer of the preset. Like if you move the preset in point of the preset in this direction, it will move in the anti-clockwise. And if you move your preset for the values above 128, it will move in the clockwise direction. And did you guys notice that as soon as I was coming closer to 128, the speed of the motor was decreasing? So that's due to PWM, which is pulse width modulation. And in this project, as we move away from the 128th value, the voltage of the voltage which motor gets will get increased in both the directions. So at 128 it'll stop, and for either directions it'll move very fast in clockwise and anti-clockwise correspondingly. So what is pulse width modulation? Pulse width modulation is, as it suggests, you're modifying the pulse width. So modifying the pulse width can be done by can be achieved by changing the duty cycle. Now what is duty cycle? Imagine you have a pulse of 2 milliseconds, out of which you have 1 millisecond for high voltage and another 1 millisecond for low voltage. This makes your pulse width duty cycle of 50%. Now if you want to increase your pulse width cycle from to 100%, so you'll give the output of if you have a 2 millisecond cycle, you give the output of 2 milliseconds high voltage. Basically you're dividing your high voltage in various sections. So that determines the percentage duty cycle. You can read the description part of this project. It's very well mentioned over there. So let me again start this one. So now when I decrease the value, it'll move in the anti-clockwise direction, and since it's directly connected to the ground, it's showing 0. That's correct, because it's directly connected to the ground. And when I directly connect this analog value to the +5 voltage, it gives the maximum voltage it can show. So for +5, this ADC corresponds to 255 decimal value. So this has a very scope in embedded, like you want to control your embedded with a joystick. This here preset can be replaced by a joystick, which is analog in nature. So by moving up and down, you can change the resistance of the joystick, and hence the ADC will be able to recognize this change in resistance, and then corresponding actions can be taken place through your coding part. That was my project. Thanks.